Okay, so we begin this talk of systems of equations. We're going to relate it to pictures that we can see, and we've done this throughout the semester. We have solved things based on pictures. So when I ask, and when you're asked to solve a system of equations, because you notice in example 2, there's no picture. You're asked to solve the following system. Well, this picture tells you what you're doing. And so when I ask you to solve a system of equations, what physical part of this picture is the solution? Where the two lines intersect. Well said. And so the way we're going to give this the solution, since these are not, we're not given them as functions, we've just been writing the value and putting in a solution set. The solution is going to be given as a point. So what is the point that represents the solution of example 1? Yeah, I count back 1, 2 in the x direction, up 1. So that is the point -2, 1. There are no other points of intersection because this is a pair of linear equations. Okay, so they only intersect once. So I'm going to put some squigglies around that, and that's my solution set. Done. Problem completed. I will put one of those on the test. Okay, so I hope that you like solving things from a picture. So please, I'm going to give you 30 seconds. Write down the solution set to example 2. Or excuse me, exercise 1. What did you write down for the solution to exercise 1? 1, 2, 3 in the x direction, 1, 2, 3, 4. Again, this is nothing we haven't been doing this semester. We're just writing the answer as a point instead of writing it as the y value associated with a particular x value. So far, are we so good? So when I solve a system of equations, whether it's linear equations like these or toward the end of this section, when I throw in some nonlinear equations, all you're doing is you're finding the points of intersection between two graphs. So there are 2 ways to solve any system of equations. Okay, and we're going to just review linear equations just to remind us of these 2 different ways. One of them is easier to apply to nonlinear equations than the other, and I'll make mention of that. So I'm just going to real quick review the 2 ways to solve. The first way is called the substitution method. And in the substitution method, what our goal is we want to substitute one equation, the value of one of the variables, into the other. And so what we're going to do, in case you're not familiar, it's been a long time since you've done this, I'm just going to write this down. We're going to solve one of the equations for a variable that can be done quickly. If there is not a variable that you can solve for quickly and easily, then the substitution method is not the right method to use. Okay. So on this equation I've given you, or on this system of equations, there's one variable that is super easy. There's another one that you could make an argument would be okay to do. And then there's 2 others that I wouldn't even begin because you're going to end up with fractions, and that creates chaos. What is the easiest variable to solve for in this system? Which y? The bottom y, yes. The bottom y. Notice it doesn't have any number or anything in front of it. You could solve for the x. You just have that negative you'd have to divide by. That wouldn't be too terrible. So you could make an argument. I wouldn't bother with the x or the y in the top one, just because you're going to end up with fractions, and why bother? So I'm going to solve for the y. And I know this is a terrible introductory algebra, but I just want to make sure everybody's awake. How am I going to solve for y? What am I going to do to both sides? Yeah, I'm going to add that x. So I'm going to write down the step because I'm feeling like writing down steps right now. I'm going to add the x to both sides. And what I end up with is I've rearranged the second equation to be y equals x plus 3 or 3 plus x, however you want to write it. Does anyone have any questions about why I picked that y in order to solve for? Are we okay? Okay, now what I'm going to do, again, I'm hoping this looks super familiar to you. If not, please let me know. I don't want to go too fast for you. I want you to be able to learn this. So now I'm going to take what I've just done with this second equation, and I'm now going to plug it, since this is y equals x plus 3, I'm going to plug that up here into the y value of the first equation. And so the first equation becomes this. I've got 3x, and then I've got plus, and then 2, but up here it's 2 times y. So instead of a y, I know I'm plugging something in, so I'm going to put some parentheses. And in those parentheses, I put x plus 3. Please don't forget that you're going to have to distribute here. That was something, I know there was a lot to remember on the last test. That was something when you were solving the exponential equations, a lot of you forgot to distribute the powers to each other, okay? And that led to a little bit of a deduction. So just don't forget that distributing. On the other side of the equation, I've got 11. Is everyone still tracking with me? You see what we're doing? Okay, this from here, this is something you can do in your sleep. You've been doing this since middle school. I'm going to solve this equation for x. So I'm going to distribute. If you have any questions, so I've got 2x plus 6 is equal to 11. I'm going to collect those like terms. So I've got 5x plus 6 equals 11. I'm going to subtract that 6 from both sides, and I've got 5x equals 5. And last but not least, I'm going to divide, and I get that the x value is 1. So we are halfway done with the problem. We've done most of the work, but we've got half the answer. When you solve a system, you're always giving your answer as a point because that's where they intersect. And so I have to figure out the y value that goes along with it. What's the best and easiest place to figure out the y value that goes along with that x value? Yeah, this second equation that we've already solved for y. So why do more work than I need to? So I'm just going to draw a little arrow here. I'm going to say, okay, y is now equal to x plus 3, so 1 plus 3. So the y value is 4. We always write our solution as a point. That is required. Okay, good notation in this class has always been something I've asked for. And so over here, I'm just going to put it over where I have some space. I'm going to put the value 1, 4. I'm going to put some squigglies around it because that's the only point in my solution set. All right, before I set you free on your problem, exercise 2, does anyone have a question about how we obtained that answer? We doing okay? Okay, then do exercise 2, please. It's the same sort of thing. There's one variable that's easier than all the others to solve for, and I hope you see it, and I hope you solve for it. If you need anything, wave your hand. I'll come to you. I'm happy to help you. I want you to do amazing on this final test that we have. All right, I'm going to get started on this. A lot of you look like you're either done or bored with me, which probably both of those are true. So I'm going to solve this by substitution. So the only variable here that even looks remotely like it's going to be relaxing to solve for is this y. Okay, that while there's not a number in front of it, there is the negative, but that's not too big of a deal to resolve. So to solve this for y, you can do two things. It doesn't matter. We're going to end up with the same thing. Some of you, I'm sure, have added the y over and then subtracted the 6. That's great. That works perfect. What I'm going to do, just because I'm a contrarian, is I'm going to subtract the 4x. So I'm going to have negative y is equal to negative 4x plus 6. And then I'm going to divide both sides by negative 1. And I'm just going to remember that when I divide by anything, I always have to distribute that. So a negative 4 divided by a negative 1 is a positive 4x. A 6 divided by negative 1 is negative 6. Same thing you got if you did the other steps. Okay, we should all be looking at y is equal to 4x minus 6. So far, so good? Anybody got anything they need to bring up? This is the only substitution I'm having you do. Now I'm going to take that value for y and I'm going to plug it in right here in the other equation. So I'm just going to go through this because most of this is algebra that I think you all know how to do. And so there's what I get when I plug in the 4x minus 6 where the y is. Just going to be cautious and not forget to distribute. So I get 20x minus 30. 2x and 20x, that's 22x. Going to add the 30. And I get 22x is 22. Now, these things don't always end up with whole numbers, but in all honesty, I make most all of mine end up in whole numbers because I'm not trying to torture you. I just want to teach you a little bit of math here. Okay, so not trying to make these take longer than they need to. Divide by the 22, and we get x is 1. Perfect. Same value as the last time. That's coincidence, just because I'm not super creative all the time. And so then I'm going to plug in that x equal to 1 into this equation for y. So I get y is equal to 4 times 1 minus 6. 4 times 1 is 4, minus 6 is negative 2. And so my point, and hopefully what you're looking at, and if you're not, if you don't see what your mistake was, you should ask a question on that. So we should all be looking at the point 1, negative 2. If we graphed those two lines on a Cartesian plane, they will intersect at that point. Any questions, comments, or concerns that you got for me? All right, well, that's the first method of solving a system of equations. In all honesty, if we were just talking about linear equations, I wouldn't even bother. But substitution for our purposes is going to be the better way to solve nonlinear systems. So I just wanted to remind you what substitution was. So going down to example 3, here's the other way to solve any system, and in particular a linear system. We're going to solve it by what's called elimination. Does anyone remember what the general premise, what I'm trying to accomplish when I solve something by elimination? Yeah, we're going to get rid of either the x's or the y's. That's why it's called elimination. So we are going to try to make this so that when I add the two equations together, either the x's or the y values are going to disappear. So notice if I was to add things now, 3x and 2x is 5x. That's not good. Negative 4y and 3y is negative 1y. That's not great. So I need to adjust these equations. Anybody want to propose to me what I can multiply the equations by to get either the x's or y's to cancel? I don't care which. Negative 2 and 3. So when you say that, you're trying to cancel out the what's? The x's. Great. It doesn't matter if you cancel the x's or y's. I'm just going to go with what I heard first. And so what I was told is we're going to multiply the top equation by negative 2 and the bottom equation by 3. So for anyone here who's saying, well, why did we do that? Great question. The reason we're doing that is because that makes a negative 6 in front of the top x and a positive 6 in front of the bottom x. And when I add those, they're going to cancel. I'm just going to call a timeout because others of you were probably attracted to the y's. And if you wanted to cancel out the y's, what would you have multiplied the equations by? 4 and 3, or 3 and 4. I'm going to do the top one by 3 because that would give me a negative 12y. And then the bottom one by 4 gives me a positive 12y. Okay, it's going to work out the same way. So I'm just going to go with this. So now I'm going to distribute. So I've got negative 6x plus 8y is equal to negative 2. And then 6x plus 9y is equal to 3 times 12 is 36. Just giving you a second to catch up because I know I get excited and go fast. Now I'm going to add these two equations together. So when I do that, this is what I was wanting. The negative 6x plus the 6x, those cancel. They're eliminated. The 8y and the 9y becomes 17y. And the negative 2 and 36 is 34. And so when I divide by 17, I'm halfway done with the problem. I've got half my answer. I've done about half the work. We get the y values too. Again, at this point, I want to get the x value that goes along with that. I haven't solved any of the equations, so there's no benefit to either of the equations. So just pick your favorite. Doesn't matter. So you got the freedom to choose here. I'm just going to go with the top equation, and I have no secret, mysterious reason for picking that. So I'm going to plug y equals 2 into this top equation and see what I get. If you plug y equals 2 into the second equation, you're going to get the exact same x value. No worries. So y equals 2. So I've got 3x minus 4 times 2 equals 1. 3x minus 8 equals 1. When I add the 8, I get 3x is 9. Divide by 3, x is 3. There's my value. And of course, I haven't mentioned it, but you're always welcome to check. This x and this y should produce the same true statement in each of the equations. And that's a great way, if you have some time on the test, to know whether you did things right or not. Okay, I'm not trying to rush along. I'm also just trying to make sure that you stay awake while we do this thing that's likely a review for you. Do you have a question before I have you do your own elimination problem? All right, well then go ahead and do exercise 3 right next door. I probably should have declared up front what to eliminate, so we're all doing the same thing. Probably a good professor would ask you to do that, but I messed that up. So anyway, what do you want to eliminate, the x's or the y's? Okay, we're going to go y's. If you eliminated the x's, I apologize. will all end up at the same place though. Okay, we're just going to get, if you eliminate the x's, we're just going to get our variable values in the reverse order. Okay, so I'm going to eliminate the y's because that's what I was told to do. And so to do that, what am I going to multiply each of these by? Yeah, I'm going to multiply the top one by 4, bottom one by 3. Noticing that I've already got a negative in there, so I don't have to worry about that. So we've got here 8x minus 12y is equal to negative 28. The bottom one is 15x plus 12y is equal to, what's that, 51? So 8 and 15 becomes 23x. The y's cancel. That's exactly what I wanted. And then negative 28 plus 51 is 23. And when I divide, I end up with the x value 1. So there we go. So whether you got the y value right away because you eliminated the x's, when you substitute at the end, you should have the x value 1. We should have the exact same thing no matter how you did this problem. Then I'm going to take the x as 1. It doesn't matter where you plug it in. I'm just going to use the top equation because it gives me more white space to write my answer in. So I've got 2 times 1 minus 3y is equal to negative 7. 2 times 1 is 2. Subtract the 2 from both sides, and I get negative 3y is negative 9. And when I divide by negative 3, I get the y value 3. And so that is my one and only solution to this. So my solution set just has 1 point in it. All right, just because we're not going to use the elimination method much beyond the linear case, I'm just going to have you do another practice. So if you would, exercise 4 is just another example of the elimination method. Let me be a better instructor. So we're all doing the same thing. What do you want to eliminate, the x's or the y's? Okay, so if you want to do the same thing I'm going to do, eliminate the y's, and then we will we'll compare notes in just a minute. All right, so we declared up front we were going to eliminate the y's. So to do that, I'm hoping that everybody multiplied the top equation by 6, bottom one by 7. And so that's going to give me 36x and then 42y and then negative 12. On the other one, 49x minus 42y is equal to something. So it's a 2 and then a 4. Is that 182? Okay, thank you. I'm pretty sure it is, but it's always best to check my arithmetic. All right, so now when I add these together, the 36 and the 49, that turns out to be 85, I believe. The 42s cancel. That's great. That's exactly what I wanted. And then the negative 12 plus the 182 becomes 170. Everybody tracking with me? Have I done anything mysterious? All right, I'm going to put a couple of these on the test. Don't you worry. So if you're liking these, then that's going to be good news. So x is equal to 2. And then one last time, we're just going to go ahead and plug that into any which equation. Doesn't matter. I'm going to use the bottom one this time just to be different. So when I put x is 2 in, I get 7 times 2 minus 6y is 26. The rest of this is just some arithmetic. You got calculators. I'm hoping you're okay with it. When I subtract 14, 26 minus 14 is 12. Divide by the negative 6, and y is negative 2. So that makes the solution x is 2, y is negative 2. I'm just going to keep rolling along. If there's a question, be aggressive, ask it. I love questions. I just have 2 more examples because there's a couple special situations. Again, you've seen this before. I don't think there's anything novel about this, but just real quick, eliminate the x's in exercise 5. I'm declaring up front, we're all going to eliminate the x's. All right, I'm not going to make you look at it too long. I just asked you to eliminate the x's, so that's not too big of a deal in this problem. It just means multiply the top one by 2. And when I do that, the top equation becomes 6x minus 4y equals 8. The bottom equation is negative 6x plus 4y equals 7. And I notice what happens to both the x's and the y's on this particular problem. Everything cancels. It's a canceling party. Yes, indeed. So I'm left with 0 on the left. On the right, I have 15. So here's the question. Is 0 equal to 15? No, that's a false statement. Okay, so when you solve your system, whether it's linear or nonlinear, whatever, and you end up with a not true statement, it's called an inconsistent system. Pictorially, what it means is that there's no intersection. In the particular case of lines, it means they're parallel. But with nonlinear, they don't, parallel doesn't really have much meaning. And so what we're just going to write here, since there's no intersection, there's no solution, we just got ourselves a little empty set right here. So no solution. I'm going to give you like 30 seconds. Exercise 6, eliminate the x's again. We're going to end up with the second special situation. In case you're still writing, I'll leave this here. So go ahead and do that, and then we'll talk about what this situation means and how we write the answer for it. Okay, again, I'm not going to leave you hanging too long on this. This is probably the trivia that you might not remember from your intermediate algebra days. So again, I'm going to eliminate the x's. I'm going to multiply the bottom equation by 2. And so I have 8x minus 2y is -4, and then -8x plus 2y is equal to +4. This time, the only difference between this one and the previous one is, once again, all the x's and all the y's cancel, which you probably noticed. But then on the other side, my numbers also cancel. So this time I end up with a system where I have 0 equals 0. That is a true statement. It's always true. I don't have any x's here to work with. So what this is called is a dependent system. And I spelled dependent. It was going to be dependent. So sorry about that. Thinking about other things today, I guess. Dependent. What dependent means is that you have the same, in this case, the same line on top of itself. Okay, it's the same line. Okay, and so what that means, we have the same line twice. So what that means is they intersect everywhere. Again, I'm just giving you notes. You don't have to write all this. This is hopefully helping you understand a little bit. So the solution set is the whole line. Okay, so the solution set so then the question is, how do I notate that? Not necessarily, because you need to relate which x's and y's pair up. So you're right in the sense that it's -infinity, infinity in x values and y values, but which ones go together? So that's a good thought. So here's how you do notate it. If you remember how we did it in intermediate algebra, this book does it different. I actually don't like the way this book does it as much as the intermediate algebra book, but I've got to show you this so that when you do My Math Lab, you can get the problems right. So what you do in this case is you say, okay, my x value is just going to be whatever x value we have. And I need to know what is the y value that corresponds to it. So what you do is you take one of the equations and you solve it for y. Okay, so I'm going to do the bottom equation because it's easier and I'm lazy. And so I'm going to solve this bottom equation for y by adding 4x to both sides. So let me bring this over here. I'm still on the screen. Yes, I'm doing a great job. So I'm just going to solve this for y, and I'm going to add the 4x to both sides. And I get y is equal to 4x plus 2. So what this says is what I'm notating here is I'm picking an x value, because any x value, just like you said, -infinity to infinity, any x value is going to work. But I need to notate what's the y value that goes along with it. Well, the y value is going to be 4 times the x value plus 2. So I'm going to put 4x plus 2 right here. And that's my solution set. That's how our book notates it. Yeah. This is just notating that I can pick any x value at all, because every point on the line is a solution. Okay, so I'm just saying that's just any x value, 1, 19, 704. Okay, so I'm not declaring a particular value. I'm just using general any x value. And now this is the format for the y value now that goes along with that x value. So if I do pick, so what this is telling me is if I had a whole weekend and I want to just sit and do this, I could say, okay, if I picked the number 5, well, what's the y value that goes with it? Well, it's 4 times 5 or 20 plus 2. So 522, that's in the solution set. I could do it again. I could say, okay, how about 7? Well, 7 times 4 is 28 plus 2 is 30. So now by picking any x value, I can create the solution set. A little better? Okay, so I just picked x because I don't have a particular one. Any x value is part of the solution. Then I have to figure out the y's that go along with it. So that's the reason for that. Okay, great question. I appreciate it. Any other questions? Okay, so now at long last, we get to the point of this section that is, well, likely, if you've gone through intermediate algebra, we don't talk about this in that class. You may have seen this in high school, I don't know. Okay, so what we have here is we've got a nonlinear system. And what it means to have a nonlinear system is at least one of the equations is not a line. Okay, so I'm just defining this for you. At least one of the equations is not a line. Oops, is not a line. I don't want to take up all my space on this, so let me get another piece of paper. You don't have to know this. In fact, you don't know this yet. You won't know this until Tuesday of next week. But in this particular system, what we have is the x squared plus y squared is 4. That's a circle. You'll learn that on Tuesday, so don't worry that you don't know that yet. So it's a circle. And then the x minus y is 2 is a line, so it looks like this. So you can see what we're going to now have is we have the potential to have one more, or excuse me, more than one solution to this. And in fact, to the system, we're going to get 2 solutions. Okay, so that's what this is going to look like. You don't need to know that. You don't need to write that down. I was just trying to prepare you for what you're going to see in a minute. The best way for us at this point in our math lives to solve a nonlinear system is to use substitution. Okay, so I'm going to do that. If you know how to eliminate on something like this, that's fine. In this particular one, to be a little tougher. So I'm going to solve, again, for the easiest variable that I possibly can find, because, again, I'm mathematically lazy, so that's what I'm going to do. So what I'm going to do is I'm going to solve this bottom equation for x, because it's one step. I'm going to add the y over. And I get x is equal to y plus 2. Now, just like we did with linear equations, I'm going to take that and I'm going to plug it into the other one. So I'm going to take this x value and I'm going to plug it in for x right there. This is where the fun starts. Yes, we're going to have a great time. All right, so down below this, I'm just going to do the work. I'm going to take the x is y plus 2. So I've got x squared and x is now y plus 2. And then plus y squared is equal to 4. So all I did there is I've taken this y plus 2 right here and I plugged it in for x. If I lose you on any of these steps, please feel free to inform me. I want to be helpful as I possibly can be. Okay, this next part is foiling, and I don't have room to write the foiling down on here, so I'm just going to write the word foil. You're going to foil that y plus 2, and what you're going to get is y squared plus 4y plus 4. And then plus the other y squared that's just sitting there waiting, and then equals 4. If you're okay with it, I'm going to do 2 things in the next step. I'm going to combine those like terms I have on the left. I'm going to bring this 4 over to the right. So I'm doing 2 things at once here. I'm going to subtract this 4 from both sides, and then I'm going to collect those like terms. And I'm going to use this space right over here to continue the problem. So y squared plus y squared is 2y squared. Then I have plus 4y. And then 4 minus 4 is 0. And then 4 minus 4 on the other side is 0. So I've got a little quadratic equation, but the good news is this is definitely not the toughest quadratic equation we've ever done. We can factor this pretty easily by taking out the common factor, which is 2y. And then I have y plus 2 left. And as I tried to prepare you for when I drew that quick little sketch of what was going on, we're going to have 2 solutions. And here are the y values for those 2 solutions. The first y value, when I get 2y equals 0, the first y value is 0. And then y plus 2 equals 0. The second y value is -2. Now, those values do not go together. Don't try to create an ordered pair with that, because those are both y values. They're each going to have their very own x value that goes along with it. And so the rest of this is just a little busy work to figure out what those x values are. As with previous substitutions, I have an equation here that I've already solved. I've got x equals y plus 2. So I'm going to, for both of these, I'm going to plug both of these in and see what the x values are. So for y equals 0, I've got x is equal to 0 plus 2. So x is 2. There's my first ordered pair. The x value 2, y value 0. For the y value -2, I say, okay, x is equal to -2 plus 2. Just about out of room, so I think it's good that we're just about done with the problem. And I get x is 0. Now take nothing that this is just reversed of the previous one. That's just coincidence because I created a nice relaxing problem. And so this time the x is 0 and the y is 2. That doesn't always happen. And there's my solution set. There's 2 values. So once you do on Tuesday learn how to graph a circle, you could graph this system and determine what the 2 solutions are. Graphing a circle is nice and easy once you know what information that equation's giving you. So we'll talk about that. All right, I'm going to leave this right up there so you can see the steps. What I would like you to do, exercise 7, I've given you another circle and another line, so you're going to get 2 solutions on that one as well. Okay, I want you to go through the steps. So I'm going to give you 3 or 4 minutes to do as much of that as you possibly can. If you get stuck, please wave your hand. I'll walk around to you. If you're watching on the video, I'm going to pause the video so you don't have to listen to silence for 3 or 4 minutes. Whatever you need. So ask whatever questions that you have. So again, I'm going to substitute. I'm going to solve for whatever variable is the easiest to solve for. Now, again, you have options here, but the one that's one step to solve for is to solve for the x, just like we did in the previous problem. Okay, that's why I left the previous one up on the screen so that you could just follow along. This one's almost the exact same thing as you just did so that you can have the tactile learning and remember and all that good stuff. So x is equal to y plus 1. So far, are we so good? Anybody got a question? Just like the last problem, I'm going to take that x value, I'm going to plug it in this the top equation. And so instead of x squared, I'm going to have y plus 1 squared plus the y squared equals 5. Again, I'm going to pause. Does anyone need anything? Any clarification? Okay, I'm going to FOIL. Okay, so this y plus 1 squared, FOIL, please do not just say y plus 1 squared is y squared plus 1. Okay, it's not. That's gonna cause you problems in just a moment. When I FOIL this, you should get y squared plus 2y plus 1. And then I have plus the other y squared equals 5. Just like last time, I'm going to do 2 things in this next step. I'm going to bring the 5 over, and I'm going to combine my like terms. So I'm going to subtract the 5 from both sides. And I'm going to collect the like terms. So I have y squared and y squared is 2y squared. I have plus 2y. 1 minus 5 is -4, and that equals 0. Now you could, if you want, either factor or perform the quadratic equation on that the way it is. But again, I'm mathematically lazy. I like the smallest numbers I could possibly deal with. So I'm going to factor out a 2. They all have a 2 in common. That's just going to make my life a little bit easier. So let me do that. My pen is not wanting to write. So I'm going to have to get a new one. And I'm really trying to, I believe in this pen. Oh. Okay, so let me trace over that in case you can't see it. I don't want that to be a distraction. Me and my Dollar Tree pens. Yes, it does. So that's a good thing that I trace over. That should become just y. Sorry, everybody. I was too concerned about my pen. So inside the parentheses, just because now I've made a big mess, that's y squared plus 1y minus 2. So now I can factor, I can use the quadratic formula on this bit right here, whatever works for you. So y squared, the 2 factors of -2 that are going to add up to plus 1 are plus 2 and minus 1. And so here's my 2 y values. So again, we get 2 y values just like we had in the previous problem. My first y value is the one that solves this equation, which is -2. The second y value solves this equation, and that is going to be positive 1. You've done 90% of the work to the problem. That's the big deal right there. If you have any questions, it's likely in that. So please ask away. No need to be shy in here. We're all friends. All right, now the last little bit is I'm going to take each of these y values. I'm going to figure out what x goes along with them. So for the y value -2, I'm going to plug that in right there. So I get x is equal to -2 plus 1. So the x value is -1. Oops, I wrote some of that and you can see it. That's not good instructing. So my first point, I'm just going to write it down here at the bottom, is the x value -1, the y value -2. And then for the y value 1, I'm going to do the same thing. Take the 1 and I get x is equal to 1 plus 1, so x is 2. And so we get the x value 2, the y value 1, and there we go. I've got one more problem that's not linear. Okay, so when you're doing your homework, please make sure as you go through that you're really focusing your understanding on the nonlinear ones, because this is the new information that's unique to this class that you may not have seen before. And so here's our next one. We've got both equations are nonlinear. This is going to be super fun. You're actually going to end up with 4 answers because you got a circle and what's called a hyperbola, which is a pre-calculus concept. We're not going to talk about how I know that, but the fun thing is there's going to be 4 solutions. So I want you to do your best that you can to solve for this. Now, substitution works great on this. Here's my recommendation. Okay, my recommendation to you is this. Take this bottom equation and solve it for x squared. It's one step. And then whatever you get for x squared, plug it in for the x squared in the equation up above. Okay, that's my hint. Give it a try and do as much as you can. And if you need me, wave your hand around and I'm happy to come to you and help you and answer any questions I can. Again, I'm going to pause the video so you're not staring at empty space. Okay, so just real quick, I've added the y squared, x squared is y squared. I took the x squared and substituted it right here. And so now I've got y squared plus y squared is 8. And so now I'm collecting the like terms and I got 2y squared is equal to 8. You tracking with me so far? Again, I know this is a difficult thing, so questions are good. I'm going to divide both sides by 2 since I can. Makes the numbers a little relaxed. So I get y squared is equal to 4. Okay, I know this was long ago, but think back, way back, when I have something squared equal to a number, what can I do to both sides to solve it? Square root. Okay, great. So I'm going to do that, square root of both sides. And I've mentioned this a bunch of times in the class. I know it's a small detail. It's easy to overlook. But when you take the square root of both sides, what do I do with my answer? The square root of 4 is 2. So what are the answers? Perfect. Great memory. Plus and minus 2. Okay, there's 2 y values that are here. That's the toughest part to the problem, okay? So if you got a question about it, ask it. I'm going to continue. Keep soaking it in. If you have anything you want to ask, I'm just going to separate these. I'm now going to do, okay, y equals 2. We're going to start with that. Well, again, like every other substitution problem, I've already solved this equation. So right here, it says x squared equals y squared. So I'm just going to use the x squared equals y squared. And I'm putting y in for the y here. So I'm going to get x squared is equal to 2 squared. Does everyone see where I put that value of y? I'm just going to slide this up so everybody can see what's going on. So now x squared is equal to 4. Again, we encountered this property. I have a number squared equal, x squared equal to a number. So I can just do what again to both sides? Yeah, again, I can square root both sides. So I will definitely do that. There it is. And so square root of x squared is x. And then the square root of 4 is plus or minus 2. Oh, so that means there are 2 x values that go with that y value. There's plus 2 and the y value 2. And there's minus 2 and the y value 2. So there's the start to my solution set. I'm not done. I've just gotten started there. That's for the y value 2. Now I got to go back up here because there were 2 y values. There was a plus and there was a minus. So I'm going to do the same thing again for y equals -2. And when I do that, I've got x squared is equal to -2 squared. Again, I'm just using this equation. Whoops, you can't see it on the screen. I'm using this equation that we solved for originally. And so I get, again, x squared equals 4. Once again, I'm going to take the square root of both sides. You can see how much fun that becomes. And once again, when I take the square root of both sides, I get a positive and a negative answer. So I get x is once again equal to ±2. So that means there's 2 x values associated with this y value as well. So here's my next point. I've got positive 2x and then negative 2y, and then negative 2x and negative 2y. And that's how I get my 4 points that solve that. Again, hard problem,